Here we go. We're going to do the beginner boost. We're on week 2. If you're here for the beginner boost, it's 11:11. Time to start something new and get going on this. We're going to jump right into it. We have here a number of things that we're going to try to get through today. So we have 2 hours. That's it. We're going to take a 10-minute break in the middle. Right at noon, so if you want to, my time, noon. And if you ever wanted the time and you're in Twitch, go ahead and do !time. That'll show that to you. Big shout out to all the people in Twitch. Also, just a shout out to the people who have been helping with these chapters, specifically Yangozu, who has been very faithfully posting the chapters as a comment. And I have been adding them so that we now have chapters. So we have chapters in every week so far. As you can see, last week we covered Markdown, GitHub, Markdown, why to do Markdown for note taking. We started talking about, there was a lot of talk about taking notes in Markdown, but that's important because that's a big part of this. You're writing your own textbook for the beginner boost. And that is an accurate statement. We are not going to have a textbook. I will write some notes and stuff, but it's more about you writing down your own notes as a part of the RWX method. Just a reminder, read and research, write about it, ponder it as you're writing about it, and explore it, experiment with it. That's the RWX method, which is just an extension of the scientific method, which we covered on day 0 when we started. So those are all things you can go back and review if you want to. But let's get going. All right, so let me just clean some of this stuff up. All right, so today, as it said in there, you should already have, stop the video right now if you don't have the following things, right? If you don't have bash installed and you don't have a terminal installed, right? If you don't have those two things, go back and watch the videos. Otherwise, you're going to waste your time. You're going to get frustrated, okay? So I'm assuming that you have installed a terminal, you've customized it minimally to your liking for now, and whether it's a Mac or a Windows machine, you've done that. And that you've installed Podman Desktop. Okay, so what is Podman Desktop? Podman Desktop is something we're going to cover a little bit later, but I don't want to blow you away. So the first thing I want you to do, everybody there, I'm going to do it with you, is we're going to open a terminal. Now, I've already got a terminal open, so let's actually close mine up, and let's go through the steps all by itself. So if you don't know, look, you're going to be opening a terminal one way or another for you. If you want to, you can full screen it. I'm going to go ahead and do the Windows version. On a Mac, it's the same. But if you're on Windows, I learned to search. I push the Windows key, and I search for. I type terminal. Okay, this is what I call search-centric command execution. I cannot tell you how to get to that command. Never done it, right? So, in fact, I do this everywhere, and it's usually its own little module called search-centric computer use, which kind of is before the beginner boost. It's like how to use your computer. People think they know how to use a computer, and then I see them like struggling with application menus. I'm like, you have not learned how to use your computer yet. So let's just take a moment to talk about it. If you're on a Mac, you want to use command space and then start typing the name. Okay, if you start typing a name, the command will pop up if it's there. If you're on a Windows machine, you just type the Windows key, otherwise known as the command key. Same with Linux, by the way, and you start typing the name or a keyword within the name of the thing you want to open. Now, you can use this technique to do all kinds of stuff. In fact, let's open this thing. Use command search. I'm going to do this. Use command search to open a bash terminal. Okay. I watch people go through the other way, and sorry about that. Use command search to open a bash terminal. Right. So I just push the tab, and the command thing, and then terminal, whichever one yours is, and then you hit enter, and it'll pull it up. Now mine was already open, but you can see I have a new one. I have changed my configurations to default to full screen. You can do that yourself. It doesn't take very much to do that. There's lots of things that people like to play around with, but the goal here is to get a terminal open. And usually if you type, I think those search tools that we just mentioned are really good because they exist everywhere. Another thing that exists everywhere on every platform is Alt-Tab. So or the equivalent, right? So Alt Tab or the equivalent will jump you through all these different windows. We're going to be doing this a lot, and it's not really part of the boost, but you should already know how to do this. If you're not Alt Tabbing right now, you're wasting time. You really are. So you're going to be Alt Tabbing between all your different apps, and that works on a Mac, a Windows box, a Linux machine. It works on iPads, for God's sake. So learn to Alt Tab, learn to do command centric, things, and get your terminal open. Okay. So if you've got your terminal open, so I have a new one over here, brand new instance of this running. Now I have a customized terminal window, and you see the command prompt. Now I've also defaulted to gitbash. Now if you don't see that, this is something. Let me show you what you might see if you're on Windows. If you're on Windows, you might have ended up seeing something like this. You might have seen this, right? And that's because you got PowerShell as a default, right? And you don't, if you can do it that way. If you want to do it that way and start it that way, then just type bash, and that will actually open up gitbash, and you can see that you are now in Mount C users ROM. Now, actually, I think that might actually be WSL2. Yeah, it is. It is. I'm pretty sure it is. I can't remember which one it is. But I think this is the problem with Windows, right? So if you installed WSL2, I don't want to get into it. Just there's a difference between gitbash, which is just a program that runs under Windows, and the WSL Windows subsystem for Linux, which is an entire Linux system that runs inside of Windows, or kind of next to Windows. It's a virtual space. It's very complicated, but I think the bash command has been defaulted to open a WSL2 instance. So that's probably not what you want. If you want to be absolutely sure you're going to be getting the right shell, and no, we are not going to go into why to use gitbash versus WSL2 today. We started talking about it last week, and we will talk about it near the end of the boost if you want to, or we can have a big debate in Discord about it. But suffice it to say, WSL2 is broken. And I can back that statement up with video evidence of it not working in several critical areas. So we've decided to use just gitbash with Windows. And when we talk about permissions, remind you about what the difference between WSL2 is and permissions, because there's a really fundamental difference there, particularly for beginners. So if you don't want to avoid all this hassle, let's just do this instead. So let's go ahead and exit out of this. Exit is pretty much a universal command. Let's exit out of this PowerShell one, and we're going to open up a new one. I clicked plus, sorry. So when you click plus, it opens up whatever your default is. I changed my shell to default to gitbash, but let's do this. Let's say I want to open, you can have, look at all these wonderful things. These other things, you probably don't have those. These are all WSL, by the way. And you can get the old-fashioned command prompt that Windows used to use, PowerShell or gitbash. Gitbash should be one of your options, right? And then you can open gitbash, and you'll get what is a bash prompt, right? And you know it's gitbash because it says up here on the top here. If you want to go to full screen on Windows, it's F11, which I can't see right now. There we go. And you can get a nice, pretty full screen like mine if you wanted to do that. I'm sorry about the ads, people. Some people, our ads are still on apparently. Let me just take a pause here. All right, sorry for that. We had ads start up. Okay, so we are back. We have F11 shows us the full screen. If you want these colors, I showed you where to look for my configuration settings. You can go look at those up. That's in last week's video. Go find that. And you get this video. I mean, you get this pretty thing. If you want to switch between, if you're in Windows and you want to switch between the different tabs, that's just Alt tab, or sorry, Control tab. And you can see it goes back and forth between the two. So you can see I have like two of them open, right? So I have to go back to my notes. So just give me a second. I'm going to connect back to my notes really quick. Don't worry if you don't know what that is. This is just my notes. I'm going to put a thing here that says notes or to do. We'll put it to do. Well, you're going to learn all this. You're going to learn all this TMUX stuff. So this goodness eventually. So use the command search. We did that. Let's talk about the command prompt again. So we'll go back to this is what you're seeing, right? So you've got a terminal open. You've got a prompt, and you potentially have just got this big full screen. So let's talk about this. This over here is the username, right? Now this corresponds to, because we're using gitbash, this corresponds to the username of the Windows user on this computer, okay? The @ sign is been around forever. We'll talk about that. That yes, if that looks like an email address, it actually is. That's where email addresses came from. This here is the host. All right, so this here is the name of the computer. And if I'm not going to tell you how to change your name for your computer if you're in a Mac or a Windows person. That's not included. But if you want to go in and change those things, that's what you do. And I changed those so that it would look nice on screen and on streaming and everything. So and so then you have this colon here, which says, okay, here's the end of the information about where we are, and then you have this tilde. Now we're gonna understand the tilde. Just for now, just know that means you're in your home directory, which we're gonna immediately talk about, and then we have this $sign. Now the $sign is like, hey, get ready for the prompt, right? And you have a blank space. And for those of you, there's somebody out there who's already seen Linux, and they've seen somebody with some fancy command line prompt out there, and they're immediately like, I want a fancy command line prompt. Okay. So I gotta put a thing here. Why simple prompts are best. Okay, so you can actually do a search for this. So are complicated command prompts long or short? You might be able to find the study that I once found. And a beginner's guide to the Windows prompt command lines. Why does people bother with them? Because it's the fastest computer human interface, period. What is it and how do I use it? Complete list of prompts, useful command prompts everyone should know. ChatGPT, wow, look at all this stuff. You probably will have a hard time finding it. I don't think it's even in my Zettelkasten. It was pre-Zettelkasten days. But there is actually a science study out there that shows that the simpler command prompts are better for you because they emphasize the command and not distracting from the command by having a big, long, annoying prompt. And if you watch people on Twitch right now who are streaming, or if you watch people on YouTube who are producing videos, they'll have like the weather in South America, and they'll have like the time of day, and they'll have like their current rank in whatever game, and they'll put it all on the command line prompt. It doesn't belong on the command line prompt, in my opinion. That stuff belongs elsewhere. I mean, you can put it down in your tmux window, like for example, if you want your Pomo timer on, which I can do. If you want stuff like that, fine. Put it there, but don't, oops. Oh, I don't have my Pomo timer on right now, apparently. Anyway, so what I'm trying to say is keep it simple, okay? Because you want it to be, so just, there's multiple reasons to not like freak out about that. The first one being is you just don't need it, and you're not always going to have it. And you're going to see when we start opening up containers are going to give you standard prompts no matter what anyway. Right? And you're not going to spend your time customizing a prompt in a container. You're just going to want to get on the container and use it. So it's better for you to learn how to interpret the default prompt on every Linux operating system out there, and AIX and Slurse and all the other flavors of Unix out there, which we'll talk about. We'll talk about the Unix philosophy, I think, probably next week. And we'll talk about where Unix came from, what the command line is, and all that stuff. But for right now, let's just get some commands out of the way so you can have fun with this. But the prompt is, a simple thing. It's not meant to be an artistic expression of your identity, right? You can make it that way if you want to use your system for editing. That's fine. But you still need to understand the basic prompts and what they do. And that's a part of progressive learning, which I think I may have talked about on the first day, which means there's nothing wrong with learning the advanced to the fancy thing, right? But build up to that fancy thing. Don't learn Kubernetes with K9S on your first day. Right? Learn the kubectl commands and the other baseline commands so that you can build up your knowledge. And you're going to see me using this approach a lot as we go, because that way you don't have gaps. And if you're forced to use one of these more minimalistic tools, like a machine with a basic prompt, don't know what's going on. Okay, enough about that. Let's move on. All right, so let's go to the next thing. We have Rob at TV, blah, 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 right? Now, just to finish up the idea about email addresses. So This here is what's actually called a host name. Sometimes it's mapped to a domain name like, oh, I don't know, skillstack.io or YouTube or whatever. And you'll notice that it doesn't have a dot after it, like .com or something like that, right? Well, those parent domains, the master subdomain, or the .com and the .io and all that stuff, those things were added. We'll talk about this again later with networking, but those things were added after the fact. And just a quick fun history lesson here. Back when they created the first, uses of these computers with terminals like this, these command line systems were used by tens of thousands of university students at the same time, and they still do this. In fact, if you go to Carnegie Mellon's online, I forget the name of it, but they have like a cybersecurity place where you can go there and get a free shell prompt and practice over their hack. You can go over there and see like 12,000 people all logged in at the same time in these multi-user Unix systems, and that host name, that part right there, was to identify that machine. So then what they started doing is saying, hey, well, we have this machine over here with thousands of users, and we have this machine over here with thousands of users, and I want to send a message between the two, right? So they would start to send messages, and it's too bad we can't do any multi-user stuff. We won't be doing that for the boost, but it's really fun to have multiple people log into the same machine. You can chat with each other using NTalk, which came out in the 80s. It's not even, all the stuff that you use every day, in the modern internet and the modern web and all that. It's already been invented. It was already there, and we were using it a long time ago. It's just become mainstream. So the idea of getting stuff from one machine to another machine required taking these names that they were given, these host names, like in my case TV, and giving them a domain. Now, obviously, I don't own the tv.com domain or something like that, so it's just a host name. And a host, what's a host? A host is the name of a computer that you have connected to that's hosting access. Okay, that's a host. So you'll hear terms like host or local host, and that's what that is, right? So this name, the name of the host, their host name is TV. It's just the name of your computer, and so we're connected, and we've got our shell prompt to it and everything. We didn't have to make any kind of remote access into the thing. Now, that is something that we need to cover using remote access using Secure Shell. Let me give an example of that, just to kind of, we used to do this all the time, but you didn't need to do that. When you just open a terminal, you just ran a program, right? And that is where you are. You're looking at, exactly where the program started, and we're going to get into navigation right now. But it could be that you would want to not just have a program on the same computer, but you might want to get a command line prompt on another system. And when we talk about networking, we're going to talk about this, but just let me give you a preview. So SSH, which opens up a secure shell to another system, is going to connect to another machine I have called Anton out there. And you can see this, I'm showing this because of the prompt. So notice the prompt has changed. So now I am on RWX Rob as the user, and I'm on Anton, which is the name of, yes, it's a nod to Silicon Valley, if you know about it. And you can see that other than that, the prompt is very much the same. And that's because I've done it that way. I've made my different systems have similar prompts, and the theme is the same because the theme is coming from the application, the terminal application, in this case, Microsoft Windows Preview. That's the terminal application that's giving me the colors and everything. Now, I want to tell you a fun story about this really quick before we get going on this. Now, this is going to be, I'll probably tell the story again later, but pay attention. Right now you probably don't need to worry about it too much, but pay attention to this host right here. All right, long story short, I'll tell you what, I'll tell you the first part of the story now, and I'll tell you the end of the story later. Make sure I remind me to tell you. When I was first hired as a system administrator, I had been doing Linux systems administration in my garage for some time. I was running my own domains out of the garage. I was catching into hackers and being hacked. And I knew enough to be dangerous, but I was a junior system administrator. And I was on my laptop. I was running Linux on my laptop, which everybody thought it was the coolest thing ever because I was running Linux on my own laptop, and none of them were. They were always using Windows or Macs, and they were connecting to these Sun Unix systems and to other stuff like that. And they had never even heard of Linux. So I actually got a chance to teach them. I talked about that a couple of days, 2 weeks ago. Anyway, while I was trying to get home for the night, I was tired, right? And I typed a command, which don't type this right now, okay? I typed a command, shut down, -h now. So there's a command. Don't do the command right now, I promise. What did it do? Now, why would I type such a command, right? Well, I typed that command because I thought I was going to shut down my Linux machine from the command line. Same as pushing the power button, basically, except for safer. And I thought I was turning my system off, my laptop. Well, guess what? I was logged in to the corporate mail server. Wah, wah. I have to share my failures with you so you can avoid them. Yeah, and I shut down the corporate mail server instead, and it was like at the end of the day, and my face probably just went white. I was so terrified because the corporate mail server was in Boulder, Colorado, and I was in Oregon. And that meant that the only way to bring the thing back on so that all mail for the corporation would continue to flow was for us to call somebody called an operator. The job is called an operator. In Silicon Valley, there's fun references to operators. These are like the moles who live next to the computers, and they take care of the care and feeding of the computers, and they go in there and push the power button on for you when you need them to. And so he actually went in there, and he went ahead and they started back. But when he went to go turn the computer back on, I told my boss about it and everything. I was so sad. And when they brought the computer back, when you go to push the button on the computer, I goes, the computer's on. Are you sure? And it turned out, thank God, that the computer, when I did the shutdown, that there was something happened with the shutdown process, that the Unix shutdown process didn't go down all the way. And we're going to learn about this at some point, probably not in the boost. But just so you know, when you're using Linux or Unix, there's multiple levels of up and down, right? And they're called init states, like init 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. So when I shut down the machine, it turned out it stopped at one of them. So it was still flowing. It was still sending network email and stuff like that. And I didn't shut the email down, thank God. And so all we had to do is reboot it and bring it all the way back up so that we could restore our network access to the machine. And it was fine. Nobody lost any email or they knew anything better. And I said, "You're going to fire me?" And my boss said, "No, why would I fire you? Are you going to do it again?" I went, "No." And he says, "Well, if I hire somebody else, they're going to maybe do the same mistake. You'll never make that mistake again." I'm like, "Absolutely not." So, yeah. So yeah, it was one of those things where I did a boo-boo. So take away this. Pay attention to what your host is, right? Now, that makes the case too. What if what if my host name had been buried among a million other crazy things in my command line prompt? Big old long command line prompt where it was really not obvious what host I was on, right? So you can see my point here. It's super important that you know, number one, what your user is, because everything you do, you're doing as that user. And yeah, you can be multiple users on the same system. We're going to get into that a little bit. And also, I'm going to have, what host you're on. And then this is the location. So let's get into that now. Let's change, less is more. Yes. Let's change the topic. And let's talk about, we talked about what a prompt is, why simple prompts are good. What's a command? What's an argument? What's a switch? And how can I find help? Let's get through that really quickly. I'm just looking at time, this time check. Okay, so what is a command? A command is something that you type, as far as you're concerned, is something that you type into the command line. Now, a command line is this idea of having a prompt asking for you to type something in and then hitting enter, having it run or evaluate or execute, printing out the results, and then setting up the prompt again. In fact, that is sometimes called, and I'm going to put this in here in our notes. Okay, what is a REPL? All right, that is sometimes called a read, evaluate, print loop. Okay, and if you're curious about this, there's actually some fun stuff you can go play around with. I actually know the creator. You can go to repl.it or replit.com, either way. And this is a fun place for you to get a REPL on things. We've talked about using this for the boost in the past. The reason we primarily don't do this, and I've written about it quite a bit, actually had a kind of a debate with the creator of this service when it first started about its value for learning, because you can't do this unless you have the internet. And I've been in a class teaching, 45 people, and they haven't been able to use it because their internet hasn't been reliable. So that's why we're learning how to use it from containers and from gitbash and all that stuff. But if you want to go out and you're anywhere on the internet and you just want to play around with an IT, you can go here and you can log in. Remember that GitHub account you created? Well, now you can just do that. You click on continue with GitHub. I already authorized it. Why does it want me to do this again? Let me make sure I need to do something really quick. Where's my flux? Where's my flux? Give me 1 second here. Where is my flux? All right. All right, so let's go. Let me go ahead and sign in. You can go try this right now if you want to. I've already showed this to people before, but we're gonna go ahead and show it again. I'm not doxing anything. Okay, so here we go. You can go start a REPL and you can do anything. You go bash, but if you know bash, you can click on that, clear to bash REPL, and you can actually write shellcode. Again, REPL is designed to learn how to code primarily, but you can get away with doing other things over here. So you can actually get a shell, and you can type pwd and ls, which we're now going to talk about. And so this is it. So the takeaway from this is REPL it. Read, evaluate, read the command. The command in this case is pwd. Evaluate it. That means do the stuff that you want it to do. That's where it sends it to the computer. And then print out the output, and then do it all over again. Loop it back. So REPL, that's what a REPL. And the model of a REPL is something that command line uses. You see REPLs used for other things besides just command line shells. Now let's talk about the word shell for a second. So the shell, you can think of the shell as being the outer shell that allows access to the inner kernel or to the inner functions of the computer, right? And the shell is designed for, in this case, bash, is designed for human readability and interaction. The idea of a shell being the outer thing that connects to other things is usually associated with human interaction, but it doesn't necessarily be. There are shells that are not for humans, but most shells are for humans. So bash is a shell. A shell is just a fancy name for the command that runs, that takes your commands, interprets them into machine, friendly stuff, specifically in this case, system calls. And then those system calls get sent to the inner kernel of the computer. The computer answers back and gives you back the human readable response, usually to the command line, right? So that's when we say. So if you had to describe the difference between a command line and a shell is a thing that provides a layer of access to inner kernel things to something else, primarily a human, and a command line is the idea of a read, evaluate, print loop, right? We're going to take something in, we're going to put it in, and we're going to take it out, right? So a REPL, a command line, a shell, those terms get used interchangeably all the time. Sometimes people mistakenly will say that a terminal is a command line. That is not true. Let me show you why. So I'm going to put that here. Difference between terminal and command line. Okay, and this gets screwed up all the time. Okay, so a terminal. Okay, this is a terminal. The thing you're looking at, that's all a terminal, right? The command line is this thing here that we're executing, right? We're executing a command, and it's doing the REPL thing, and it's printing out the results. That is a command line interface. What's the difference between a terminal and a terminal interface and a command line interface? A terminal interface is any interface that uses an ASCII text terminal. It doesn't necessarily mean that it's a command line interface. So most command line interfaces are also terminal interfaces, but not all terminal applications use command line interfaces. Let me give you an example of that. So like if I run the fishies command, I have a program that has a terminal UI, right? And there's actually ASCII games that you can play that use your keys to move around. Some of them even use your mouse. Now they're all using a terminal interface, but they're not using a command line interface. You get it? Okay, so make sure you understand the difference between a terminal, a TUI, 2E, whatever, a command line interface, and of course a graphic user interface, which is anything that's got graphics widgets in it. So you're going to hear those terms thrown around a lot if you're just new to tech. You probably already have, but it's important that we make that distinction. All right, so that's the difference there. What is an argument and what is a switch? Let's go to that really quick. Man, we're running out of time so fast. All right, so let's actually jump right. So an argument, let's actually jump into the ls command. So let's go down. I'm going to show you the ls command, and we're going to show you an example of that, and then we'll go deeper into the ls command. Okay, so the ls command, which you can do right now if you've got your thing open, is, and I'm not in the right one here. Am I? Oh, I've already logged in. I need to make a new one. Yeah, let me make a new one. We got that one. Oh, I'm on Anton. That's why. We need to exit out. Oh, I'm on the wrong machine. What do you know? Okay, so now, see, I typed exit, so I shut down my remote connection. Now I'm on my local machine, right? So let's talk about the prompt. Again, I told you the tilde means home. And where is home? Well, for this user on Windows, now this starts to look more like Windows now, right? C users Rob. Now, it's like, what? It's /. If you've done anything with Windows, you know that Windows uses backslashes, which is why we're using gitbash, because we don't like backslashes. They're horrible. Windows should never have done that. It was a horrible idea. And so here we are in C users Rob. This is my home directory. That means when my computer starts up, that's where everything refers by default to that location. There's other places in your system. And let's talk about file systems for a second. Okay, so a file system is just a way of navigating the computer. So we talked about the command already. PWD is a command. I executed one command and it showed me all the stuff, right? You see another command and it shows me all my current files in here. Clear is another command. Let's put clear in the list here. Let's do clear in the list. I put clear in the list. Clear the screen, and I don't want anybody to tell me to use Control L. Bite your tongue. Don't do that. You never want to use that, especially when we get into VI mode. Okay, so here we go. So we've got the ls command, right? The ls command lists all the files that are there, and all the stuff, we'll say for now. And how do I, do that? So I want to see all of it, like the long listing. ls-l, that's an option, otherwise known as a switch. Strictly speaking, I mean, splitting hairs on what they mean. And a switch is usually just one small letter. But as you can see, you get this longer output, which we're going to talk about later. So the thing to take away from this is there's a space in between each of the arguments, and some of those arguments are options, and also some of those options are switches. So it really depends on the application, right? But there are some general standards about how to do this. I have strong opinions about this as a rabbit hole. If you want to go study my Bonsai alternative for modern computing, I'm just going to put a plug-in for it right now. If you are a veteran or interested in this kind of stuff, you go to GitHub, RWX Rob Bonsai. I have strong opinions about how the command line interfaces since the 70s are broken and should be fixed. And I've created a library to deal with that. So, but that's more for the veterans out there. But I do want to mention it. So, as a convention in the 70s, for some stupid reason, in my opinion, they decided to put dashes and double dashes in front of everything, right? To separate the arguments from other arguments, even though the order really actually does matter. And this is one of the things that confuses beginners the very most, is what order do the arguments come in? Is it an option or an argument? When do I put it there? So like an argument in this case would be just like a name like that, right? So that says, hey, I only want to list the one thing here, not all of them, right? So let me restate. These are all arguments, okay? In fact, even the command is actually an argument, but we'll get into that later. So you could say this is the first argument and this is the second argument, right? It just so happens that this first argument is also an option or a switch, and so it has special meaning to the ls command. And then this one is more of a value. It's like an input value. If you were to have a machine and you would say, okay, that's the one thing I want to see, right? So they're all arguments, but this it would technically be called more of an argument, and this is more of an option if you're going to start to split hairs about it. But you're going to hear people interchange those terms all the time for better or worse. But when I say you need to add dash dash whatever, that's what I mean when I'm saying options or arguments, okay? And you can, there's, wide conversations about that, but now you know what those are. I've written commands that actually, when we get into scripting, we're going to talk about arguments a lot more, because that's one of the main ways to pass in data to the command to change how it behaves. Okay. So, and that if you know math, then you recognize the term immediately. It's an argument to a function, right? That's where the term comes from math. How can I find help? Switch and flag are the same in this context. Switch, flag, and option have what is a switch, flag, or option? And honestly, I don't think we should split hairs there, because this is just for beginners, right? So when we start to get into scripting, we will start to break that down more. But just understand that for right now, arguments, switches, flags, and options are the stuff that comes after the command. Okay? Because I don't want to overly complicate you. But as you're reading about, we got adds again. All right, adds are disabled. So the difference between a terminal and command line. Let me get my... So let's talk about that. We talked about the difference between... All right, let's actually get into some of the commands. Let's talk about a file system, what they are, and the bash shell, and then we're going to have to stop. I only have 8 more minutes. And then, but here, get ready to start entering commands from the command line, okay? So let's go back here. So first of all, let's take a look at what this looks like from the graphic perspective. So let's if you don't know how to do it, go ahead and pull up your Explorer, and I'm going to call the File Explorer in Windows, right? Hopefully I won't give too many things away. So this is a regular good old Windows File Explorer. You guys have one in Mac too. It's funny. I had a person I was helping to mentor who had never experienced the concept of a folder or a directory and containing files. And the Mac interface actually complicated the issue for them, because the Mac interface had recent, right? That was the main thing. It was just recent. So it was just this arbitrary idea of the most recent thing used, and it didn't by default when you open the Mac Explorer. There was no hierarchical organization of anything to look at, and so I actually had to take this particular person's only time ever through the idea of a rooted node tree, or the idea of there's a folder that has some files in it, and then there might have another folder inside of it, et cetera, right? And that's what a file system is. I actually tried to use the concept of a file system to help this person understand how the internet works, right? How a website is broken down into the same sort of data structure, which, and I'm going to use that, I use that word very deliberately, a data structure. So if you take CS 101 or anything like that, you're going to learn data structures and algorithms. So data structures are the ways of organizing data so that it can be manipulated and traversed and navigated and accessed and all of that. And you're also going to talk about algorithms, which is the steps that you can follow to do things with those data structures, right? So I want you to learn the name. If you want to sound fancy, if somebody asks you what a file system is, you say it's a rooted node tree data structure containing information in the form of files, right? And directories. And spoiler alert, guess what? Directories are files. Yeah, they actually are files. In fact, there's a common saying, I'm going to put it out here. Everything is a file in Unix. Okay, and you're gonna see this a lot. All right, so everything is a file, and more specifically, an inode. You can think of inode as being the term for information. inode specifically. And we're gonna come back to this a lot. Okay, so but understanding that everything is a file or an inode is super important. But at the higher level, when you're thinking about the graphics terms, I'm bringing up the graphics interface because most people already are intuitive about how content is organized, right? You've got these folders, which is a popular Macism, and then you've got the stuff that goes in there, you know, and like here's me, you know, doing my cadence and my gearing ratios and stuff like that. And these are individual files inside of here. Now, you can have different subdirectories within there, subfolders if you want to call them that. But the reason, and so the term folder and directory is interchangeable. Directory seems a little, you know, odd because I mean folder on a macro scale sounds easier to conceive, but the directory is more accurate because the directory lists everything that's in there, not just the files. I mean, a folder would suggest that, you know, you've just got other files in there. It wouldn't suggest that you've got other folders inside of there, which you would never find in a file system in the real world. I mean, generally speaking. So I'm going to use the term directory. The command for this is dir on Windows if you want to see the contents of a directory. It's important that you start using that term directory. But a rooted node data structure is just this way of organize everything so that it has a root, and then under the root is this kind of, you know, upside down Christmas tree on its side of all the stuff that goes inside of that. Okay, and you're going to see that data structure a lot. We're not going to get into it any more than that. But that is one of those examples. And so let's actually talk about a command for this right now. Let's go back to our thing here. So if you type ls, you see this. You can type ls-l and you see a bunch of stuff, but you see how all of the stuff is only in this directory, right? And you see immediately that there's different colors. And what are those things in there? I'm debating about how much detail to go into right there. We only have about 4 minutes. But suffice it to say, they're all different kinds of files, and those different files have different kinds of permissions. And I don't want to get into file system permissions right now. We're going to do that next week, if not tomorrow. We need to get you a running Linux machine container before we end today. So the only commands we're going to learn right now are pwd for showing the current directory. All right. So pwd shows, whoops, where am I? All right. Hey, thank you for the sub. So let's do a pwd. So we do the sub c users rob, right? So we see we're in the home directory, right? You can actually find that exact same directory in your graphics interface, and I encourage you to do so. Take a moment to see that they are the same thing. So like, if I don't know where it is, but let's go in here. So let's go all the way back up at the risk of exposing something about my system. So let's go to this PC. Okay, so this PC. All right, so there's C. So I got C over here, right? Okay, so let's go into C. I'm going to open that up. God, I'm almost full. My hard drive's almost full. Ooh, we got all this fancy stuff here. If you've done anything with your, you know, mods and stuff on your game computers, you probably know about this. We got users right here. All right. And then we're going to go under users. Okay. Oh, there's Rob. All right. So let's go into Rob. And look at all that jazz. Look at all that stuff that's in my home directory. Right? This is my home directory. And there's a bunch of files here. These are hidden files. We're going to go through all of that, just not right now. And so this is, you can see all of the different things that are in here, right? And it's surprising, it's not surprising, is if I do ls, you'll see I have the same files here. They might not be in the same order, but they're the same files. See, they put vagrant file a little bit earlier, but they're the same. They're exactly the same thing. So what the point is that that we have the same organization from the command line as we do in the graphic user interface. Okay, you know, you're going to see that you can do things on the command line to manage these files much more quickly. In fact, that one person I told you about understanding the commands and everything, when they found out how to rename files and move a whole bunch of files at once with a single magical command from the command line, they immediately obsessed about learning all of that. They were so, because they had been, dragging files around and moving them around with the graphic user interface their whole life and did not know how powerful it was to do stuff from the command line, even with just relating to files. And to a veteran of Linux or Unix, that's like, well, yeah, but to somebody who's never seen it, like moving all the files you don't want into some other thing, or moving all the files with a particular format or name or permission into a different thing and filtering them all at a single command, it's very powerful. So anyway, something that's interesting here is you can actually, you see if you click on that, look familiar, C:\users Rob. Looks a lot like our pwd command, right? It's because it's the same thing. It's just the Windows interpretation of it. In fact, you can actually go back and forth between the two. So I think everyone's got that association, right? So we can use the graphic interface for these files. And here's something fun. Watch this. I can actually make a new file in here. So let's make a new folder in here. We'll say my sample new folder. And I'm putting spaces in there on purpose to be annoying. And now when I look ls, right, and I can type, and we can do tab completion. I do my tab, and you can see what it does. You see what it did? It put the backslashes in front of the spaces, and we can see that it's there. Now, if I wanted to go into that, what if I want to delete it? It's there, right? So let's actually that's file manipulation. We're not going to do that today. We're gonna do it next week. Like how to create files, how to change the permissions, how to move them around. That's different. I just want to show you that if the file is there, then it's also here, right? So it's exactly the same thing. We're just using we're using the command line interface, shell interface, versus the GUI graphic user interface. So we're trying to remove this, and it's going to be like, uh-oh, it's a directory, can't do it. Have a do command, which you haven't learned it yet. rmdir, we'll delete it. Now that might fail for you if it has something in it. But see, now the file's gone. That's all I'm trying to show you, is that the graphic interface and the command line interface are the same. You're looking at the same files, okay? That's because we're using gitbash. And when we start talking about file manipulation, this is the number one reason we used gitbash on Windows or bash on shell on Mac, as opposed to the WSL and the other options there. And that's because you're not dealing with the same files. It's very hard to deal with the same files. It can be done. It's just, for beginner, it's not particularly intuitive. So I just want you to understand that gitbash is doing the same thing to the same files. Okay. And in fact, no, Rob, I was going to go into permissions. Let's go ahead and take a break. It is 12 o'clock. When we come back, we are going to finish, for you on YouTube, it'll be instantaneous. We're going to do a couple more of these commands. We'll talk about the directory organizations, the hierarchical thing. We did that already. And we're going to actually get into containers, and we're going to start up a container, and we're going to install Linux, and you're going to start using Linux from a container. So that's coming in a few seconds. All right, welcome back from the break. If you took a break, hopefully you did take a break. Let's get going with virtual machines and containers. Let's talk about this concept at a very high level. Now, before we get into this, somebody out there is going to write nasty things in the comments or something about this conversation about containers and virtual machines. I could spend the entire hour just talking about that. Suffice it to say that containers and virtual machines are two different ways to do something on a computer that is not using effectively what is on the computer, the host computer, like we talked about, right? In a nutshell, it's a way of sort of making another computer inside of a computer. And when we're talking about a virtual machine, it literally is doing that. And that's the only difference you need to know between that and a container. Okay, so, and there are lots of pretty graphics. Go out there and do your own research on this. If you want to understand the difference between a container and a virtual machine, now is the time to do the research, okay? To give some context to this is super important. When we did the boost last year, we did a virtual machine instead. And if you remember me just SSHing and connecting into Anton, that is a virtual machine that's running on this computer, actually, that was created last year. So using a virtual machine as a way to encapsulate work, all the stuff you want to put on that machine, is one way to do it. And another way to do it is to use the same operating system, but to share that operating system in a safe way and to divvy it up into containers, all right? And specifically Linux containers. And so those are two ways of managing separations of concerns. And, if you know about Docker, you know that, they have like a ship and they have all the Docker containers on there, and you can ship those containers around. And the idea of a container is that you can put an application and everything it needs inside of a container in this nice, happy thing, and you can send it someplace and then have it run there with the base assumptions about it needs this much space and this much size to run and everything. And it's just a modular way of handling work. If you've heard anything about cloud, which if you haven't, you're under a rock, then you know that cloud is fundamentally dependent on these concepts. Either a virtual machine, so if you've heard of Amazon or Azure or any of these things, when they start up or DigitalOcean, their droplets over there, whenever they start up a new machine, right, they have a host machine, which is usually a big thing, and then they start up virtual machines inside of those. And in every respect, those virtual machines they function just like a virtual machine. In other words, they can have their own virtual disk drives. They can have their own virtual USB drivers, so you can plug USB sticks into them, which is, by the way, a reason to use VMware versus VirtualBox, which we won't get into. We did that last year, though. If you want to go watch last year's boost, we do get into that a lot. In fact, we made a decision to use containers. We used containers 2 years before that. So the best way to safely encapsulate the work that you're going to do boils down to a decision about, do I want to use a virtual environment, which is something we haven't even discussed, but that isn't even related to a container. Do we use a container or do we use a virtual machine? And so for the purposes of the boost, we are going to use a container. Now, in order to use a container, you need to have a container engine, and the engine has to be built. Modern containers are Linux only. They're, BSD and other Unixes do have them, but when you hear the word container or image or Docker or any of these things today, they're specifically talking about LXC, which is a Linux container. That means you cannot have a container without Linux. And you're like, Mr. Rob, I don't have Linux on my machine. How the hell am I going to run a container? All right, well, that's what we're going to talk about. And the reason that it's nice to talk about what a virtual machine is, and this is, your mind might go crazy here, but we are going to use a virtual, we're going to use a container engine that runs a Linux virtual machine behind the scenes that you can't see in order to run containers for you. Okay, that is what Podman Desktop is. So let's go back to Podman Desktop. And show you what we are. So right now, if you haven't started up Podman Desktop, do your little command to start up Podman Desktop, right? Now, if you had any trouble installing it or anything, please hit the Discord on that. You should have this installed already. And I'm going to go ahead and trash. I'm not supposed to have this one here. Prune images. Okay. Pretend you didn't see that. All right. So this is the Podman Desktop. Okay. If you haven't updated it, make sure you click on update to 4.5. Wait, what? I did that already. Okay, yeah. Make sure you're updated to the latest. So it's down here. You don't need to do this stuff. It might say install kind. If you want to do that, you can, but that's a Kubernetes thing. So this is the Podman Desktop. Now, to be fair, I have not used the Podman Desktop more than 20 minutes, actually, before I started this, but I have used Docker Desktop a bit. And we are going to go through the graphic user interface for a bit. But I want to come back to ads again. How are we getting ads again? Sorry, I had to pause for that ad break. Okay, so we're back to Podman Desktop. So Podman Desktop is a graphic application. I've talked about this before. that contains a virtual environment, a virtual machine that's running Linux, on which it runs the LXC container engine. It runs a container engine. And what does that mean? That just means that we can run containers using this GUI if we want. All right. So for the rest of the hour, we're going to play around with containers. So you should have Podman Desktop up and running. We're going to play around with running containers in here, and we're going to run them using the GUI, and then we're going to run them using the command line. And we're going to do both combined, kind of like we did when we were browsing. All right. So I mean, as I said, I'm brand new to Podman Desktop. Why Podman Desktop over Docker Desktop? I talked about that before. The long story short of that is Podman Desktop is open source software. Docker is not. All right. That's all we're going to say about that for now. So when you fire up the desktop, you can see here, this is the container. This might be different for you depending on how dated this video is for you. But here we have containers. You can see there's no containers. What's the difference between a container and an image? So we come down to this thing, pods. What is a pod? Oh my God. What's a pod? What's a container? What's an image? There's like all of these different things. What are volumes? All right, let's talk about all these things right now. So let me go back to here. All right, so here we have, here's the command you could run from the command line using gitbash. If you want to do that, you can go ahead and run that. We're going to do that later though. And let's go first of all to containers. Create a container. Let's just play. Create a container. Container file or Docker file. No. Okay, so I like that Podman allows us to make a thing called container file instead of Docker file now. That's interesting. It used to be you had to call them Docker file, but Podman is from Red Hat and they don't want anything to do with Docker, so they allow. This defines what goes into a container, and there is on the list of things to do way after we get to our bash scripting. We might come back and actually make our own containers. Okay. For right now, we're just going to use existing containers to get you going and navigating the command line. But eventually, you might make your own. So let's say I want to use an existing images. Oh, so the first thing we learn is you can't have a container unless you have an image. So listen to this. A container is an instance of an image that is running. Okay. And a container is an instance of an image that is running and that you can connect to and use and everything like that. Okay. And all a container fundamentally is at least one executable, something that can run a command, and a protected environment in which it lives. In other words, it's separated from the rest of the operating system in terms of like what files it can see, what processes it can mess with. It's, for all intents and purposes, it is separate from the host system, and it runs within the container environment, right? And that's what makes it safe and protected. And you can, ship container images all around, and you can, if you're doing development, you can have that container run and have it be the same kind of container in multiple places. And we're going to show you that. I'm going to use a container for that kind of thing. It's kind of like, and yes, it's like the instance relationship in object-oriented programming, right? So an image is basically kind of like the class. It's the image, and the container is a running instance of it. So for example, we talked about Linux a little bit. We talked about Ubuntu Linux. That's the Linux we're going to be using today. We're not going to get into that right now. When we talk about Unix philosophy next week, well, I think we'll get into that. But for right now, just know that's the one we're going to be using. So I need to get an image. Well, where can I get an image, Mr. Rob? There are a number of image registries on the internet. Okay, and I need to put this down here. Okay, so there are a number of image registries on the internet. Now, the default standard registry location is hub.docker.io. Now that is for legacy purposes. So you should probably, even if you don't want a Docker one, you should probably go out to docker.io or docker.com and Docker Desktop. If you play with Docker Desktop, you'll see it's the same as Podman Desktop. Okay. But the point is you probably want to create an account over here so that you can log in and get the stuff over here at its default location. So images are stored in registries. what are the main registries on the internet for open images? Well, you have the main one, which is hub.docker.com, right? But this is surrounded in controversy. I won't get into it right now. Is it hub.docker.com or .io? I think it's hub.docker.io. Someone know? Why am I not getting it? What happened to hub? What? There it is. That was weird. Okay, so here you go. Docker hub, right? So I'm just gonna. So we're gonna talk about the registries out there that you can get to really quickly. Okay, the main one for Docker is Docker's hub. This is the default, and it is now hugely controversial because they have really screwed open source. They basically told all the open source project they had to pay overnight, and I'm misrepresenting it. I'm going to get into trouble, but suffice it to say that hub.docker.com, every major project is like running for the doors to get off of docker.hub because Docker continues to do stupid things that are against the best interests of the open source community and themselves, actually, and they're shooting themselves in the foot. And seriously, most enterprises can't get off Docker fast enough. So, but it still behooves you to have a Docker hub if you're an individual user. It still behooves you to have an account on hub.docker.com so that you can pull down images from the default location. Why does that matter? So when you say pull an image and you go search for images, you can see Ubuntu, you can search for an image here. And it's like, oh, this is just among the images that I have, right? Well, I don't have them. So I'm going to do this. I'm going to say pull an image, image name, image to pull. If I type Ubuntu with nothing else in it, it defaults to Docker Hub. Okay. And you can see that it's downloading the image and it's ready to go. So now I have an image and we can run that image. But you can see right here that it's like docker.io/library/Ubuntu. And that's interesting because Podman added those qualifiers in front of it. If you use the Docker tool, it doesn't do that. And the reason Docker is still around is because Docker started all of this, but then it's fallen out of favor. So you're going to still see references to Docker, but the whole community and enterprise and everybody are all moving away from the reference to Docker, which is why I found it so interesting that you can actually use, you can actually use the term container file instead of Docker file anyway. So we're back to containers. So we have, okay, so we pulled an image. That means we got a copy of the image. So it's like we took that container hub. Now we're going to make an instance of it run. So let's go ahead and run one. So if we click on run the image gives us all the parameters and the arguments and everything that we would need to start up a container that uses that image. So you can say, it's like something here, volume. Okay, what's a volume? A volume is something on this computer. So if you wanted to make a directory on this computer that you can use, so you could even go into your users directory and find, where's that folder? Do we have another folder? Let's make one. New folder. Can we do it? Yeah, I think we can. Did it do it? Where'd my new folder go? Oh, I don't think it did it. Good old Windows. But let's try it. New folder. No. I don't like GUIs. Oh, there we go. Now we got 3 of them. All right, so let's rename this one. So let's we're going to do this all from the command line later. That's why I'm having problems. So let's do this. Let's say, and so we're kidding. Thank you for the gift subs. So we're going to say mounted, we'll say, okay. And, or how about this? How about we say shared? I mean, you can name it whatever you want, right? So now we have a folder. Let's go ahead and select that. It doesn't have anything in it. Select folder, shared path inside the container. So this is where in the directory path do we want this to appear inside of our brand new Linux container, and which has got its own, it's kind of like its own machine, its own operating system. It's not really, but it's separated out. So let's go make it. So let's say we want shared to be in /shared. Okay. So that's at the root of the file system, and that's where we want it to appear. We're not going to talk about environment variables right now. Just know that this is a way of passing information that is specific to this specific container. This is very critical if you're going to get into Kubernetes stuff. But we're going to skip that for now. Port mapping, we'll talk about that later. But like if you wanted to run a web server inside your container, you'd have to, all those ports and everything are protected. And unless you say, no, I want that, port that has my web server on it to be accessible from the host operating system or anybody else on the local network, I need to map that port to another port on the host operating system. Otherwise, it's protected and contained. That's the whole point, right? So we would add a port there, but we're not going to do that. We're just going to add a mount point for a volume. And then we're going to go ahead and start the container. Now, in case you're wondering, we're not going to be doing this long term using this graphic user interface. I'm just trying to show you the nice happy way of doing it before we get into doing it from the command line. So here we have a running container. It's named something, and it's there. Now, well, Mr. Rob, how do I get a terminal? The whole point of this boost is to do a terminal. How do I do a terminal? Well, you can actually, Podman Desktop lets you do this. We can skip all the Kubernetes stuff, which is fine. But hey, look, oh my gosh, open a terminal. I can actually open a terminal. Whoa, that's right. I've got a terminal. Remember when I was telling you about simplified prompts? Look at how tiny that is. Remember all that stuff about simplified prompts? Remember I was talking about that, right? About how, you look at that. See, that's got a hashtag in it. And like, Mr. Rob, I cannot read that. Is there anything I can do to improve the quality of this terminal? No, not really. So this is why we're not going to use this terminal. We're going to use the terminal that we spent all that time installing to access to connect to it. So let's do exactly the same steps that we just did, but let's do it using gitbash running a shell in that, in our nice pretty shell. Okay, so you'll see I type exit and then it just kind of drops me. This is definitely not the way to go about this. Look what it shows you though. It shows you that it was running the bin bash command, which is the main command to run. That was in, as I said, a container fundamentally contains one command, and then that command is the primary thing that's running inside of the container. And so let's go. So then we have logs here. There's no log output. There's inspect. Ooh, it shows you what image it came, where it got the overlay. That's kind of cool. I've never seen that before. So we have our terminal here. Oh, look, I opened up a new terminal. I don't need one though. So, I mean, I like some of this stuff though. Oh, wow. This has got the Kubernetes pod. God, we got to come back to this. This is one of the reasons that I'm actually really excited about Podman, because a pod is yet another abstraction that contains one or more containers. It makes it into a pod, and a pod is the fundamental unit of Kubernetes. Now, a lot of you are watching this going, I want to get into Kubernetes and DevOps and all that stuff. You have to understand containers fully before you can even touch Kubernetes, because it's all about containers, because containers are one or more, usually just one container goes in a pod, and then the pod is the thing that's used to do all of the deployment across the entire enterprise. You can think of Kubernetes as being kind of like an operating system for an entire enterprise, where multiple computers are brought together to effectively become a single mega operating system that then can run separate running programs and stuff like that in the form of deployments and all kinds of different things. That is what Kubernetes is. Kubernetes is to the enterprise what Linux is, to you on the desktop. You have lots of running programs all running. So that's just an open summary of that. I'm going to be doing a bunch of Kubernetes stuff later today, actually, and in my own home lab. And there is another home lab init series that I'm going to start streaming more of outside of this to cover how to set up your own. In fact, I'm going to start my series over again and start setting up my own Kubernetes cluster on my rack back there, if that interests you. But that is more for people who've already mastered containers. The reason I'm telling you that in the boost is because if you have any prayer of like doing any of this enterprise DevOps and cloud infrastructure, you have to master containers, period. So just, pay attention here as we go about it. So this is just the happy GUI, but as you can see, there's a number of problems with the GUI. First of all, we don't know what the underlying commands are that we're executing, even though we'd have to do those things from the command line. So it kind of helps you, but it also, as most GUIs do, it hinders you because it keeps you from doing what you really need to do, which just means I need to get into that thing, right, and see what's going on. So we have this container is still running, and I'm going to jump to the command line. So let's go to our command line here. So here I am, and you're like, well, how do I see that it's running? So that there's in our list of things here, we kind of skipped a few things. So we're going to cover which we covered exit, but let's cover which, and let's cover how can we find help? Okay, and I think I might have to just move this down here. Let's do exit. We over that one. Okay, so let's go back. So what does the which command do? Which command looks through your path for the command to see if it exists. You can effectively do the same thing with type and which. If you're a veteran, I'm going to put a question out there for our veterans. What's the difference between which and type, and why would you use one over the other? We're not going to talk about it right now and for the beginners, but all the beginners need to know is that which Podman will tell you whether that command exists, right? If it does, where it exists, if it's there. If it's not there, so which Docker, you'll see there's no Docker on there, right? We have no Docker on the system at all, just Podman. You can type the same thing. Anyway, we'll get into that. So that's what that command does. You really don't need it for anything more than that. And that just ensures that you have a command that's in the right place that will run when you just type it like this. We're going to talk about what the path is and how to execute commands and all that later. So Podman, right? So if you just enter Podman by itself, it's going to be like, nope. And most commands will kind of help you out, right? And so you can use your mouse for this and scroll back up. I'm going to show you ways to not have to use your mouse for this, but you can actually read the help, right? So this is where, fundamentally, this is where most help is found, is in the command itself. And most commands will have a -h or a -help or whatever. And most commands, if you don't put anything after them at all, not all, but most will give you the help so you can go in there and do it the right way. But you can usually guess by using a -h or something like that if you want to learn to help. So as you can see, here's all the commands. Before we leave this topic of like looking up help, there is another command. There's three other commands on Linux to get help, right? And I'm going to put those in here right now. And we're going to say, so you have -h, right? So you have the man command, you have the info command, and you have the help command. Okay. And these are all commands that you'll become familiar with over time. I don't want to belabor this point too much right now, but if I say man podman, it stands for manual. Podman, you can see that there is no man. Tell me to scroll terminal with mouse. Yeah, look, if you don't know about how to not scroll without the mouse yet because you don't have tmux yet. So apropos and what is, I don't really like apropos and what is, but you could list them there. People won't know what they are, and they're not on most things. But you can put these here. Okay, so the main ones are, there's also, anyway, there's no TLDR, unfortunately. So, but you can type help. Okay, the help, by the way, the help comes from bash. The help is specifically for the bash command. So if you type help ls, it'll like, oh, I don't know what that is, right? If you type help exec, it'll show you that section of the bash man page. So if you type man bash, there's no man command because I'm on Windows. Well, I'm kind of getting ahead of myself. Maybe we should do this after we do the Podman Connect because we're still in Windows. I know it looks like bash, but we're not in bash, right? We're not in bash. We are in bash, but we're on bash on Windows. We're not on bash on Linux, and that's what we want to get on. All right, so let's connect to this thing. Actually, let's just trash this one and do the same thing from the command line. Okay, so let's go ahead and trash that. Boom, it's gone, right? Before we leave the idea of registries, though, it's important that you know that there are other registries you can go to. So like quay.io is another registry. GitHub has a registry. So it's usually the first thing that goes right here. But you can see right here, it gives you the command to use, right? And so you can go ahead and copy this to the command line, and we can type enter, and this will pull the latest image, and it will run our image. Hello, Podman world. So what did that do? That pulled down the image, and then it ran the command inside of the image, and then it exited. Now, the command that goes inside of an image can do different things. Sometimes that command is just meant to execute and stop. In this case, that's what we had, right? And sometimes it's much more. Sometimes the thing that you're going to run is a shell that's running inside of an entirely, simulated Linux environment. And as far as you're concerned, it seems like an entire Linux operating system. And so let me give you an example of that one. I've already made one that is my personal workspace environment. Now, this has been designed, there's things missing from it, but you can try this right now at home, and it is on Docker Hub. Unfortunately, I haven't moved it over yet, but let me show you the command. So as you saw already, if you forget the command, say here's the one that just executed. Let's actually, look at it. It says there's that container exited, but it didn't delete it. You see that? It still kept it around. Is it still there? Yep. Okay. So when we ran this command, a couple things to note here: podman run quay blah blah blah. Right. So we use the run command. What did the run command do? The run command pulled down the image and then ran the program and exited. Right. But it kept the container around. So this container has been exited, and I could restart this if I wanted to. You see, look at when I run it. Look what it does. It runs and goes off. Why? Why does it run and go off? Because it's only running that little command. Now we can't see the output when I do this. When I'm clicking on run, we can't see the output, right? It could open the logs and see them. See, every time I run it, watch. Every time I run it, it's going to do it again. It'll put another log thing up. Why is it doing that? Because it's just a container that runs a command and exits. It's not a container that runs a command that keeps running, right? But it still keeps the container around so you can run it again. And again, this is a container that's been customized to have, it's an instance of the image itself, right? So I can actually run another container. Watch. If I do another one, what's going to happen? It's going to make another one. See that? Why did it make another one? Right? It made another one because every time you run it, unless you tell it to use the same name, it's going to go make a new container. What is a container? A container is an instance of an image. Whether it's stopped or exited or not, it doesn't matter. It's an instance of an image. These are all the same. They're all instances of the same image. And if you go to image here, you can see these different images, right? So there's the Ubuntu one, and here's Podman Hello. So we have only one image, but we have two containers. How is that possible? Well, because these are separate. And you see how they were given random names, right? And we can trash those. I can run them. They're both doing the same thing. They're just completely contained and separate from one another. And that is really valuable. When you get to cloud native computing infrastructure development, you're going to see that this idea of being able to run 1, 2, 10, dozen, 100 of the same containers that do identical things next to each other in completely separate spaces is a very valuable thing when it comes to distributing load for work across the enterprise. I mean, that's kind of a future thing, but I want you to understand why this is important, why containers are so important. Yeah, there's two different objects from that class. So if you know about object-oriented programming, maybe that helps you. So as you can see, we can delete these things though. Actually, let's add something. Let's continue to use the same one now, but let's add some other stuff to it. So let's actually give it a name, and I don't remember the name. So let's do this. Let's do podman run -h. I want to see all the commands that go with it. Run. Okay, I got it wrong. -- help. Remember that thing about switches versus thing? Okay, so here we have, I'm scrolling. I know, there's a way to not scroll, but I don't want to teach it to you yet. We're going to learn tmux for that. So you can go and see, man, look at all these cool things. We're not going to go through all of this stuff, but this is where you go to look for this stuff, right? So where's one that we can set the name? Here we go. Assign a name to the container, name string. All right, let's try that then. All right. So let's go back. I'm pushing the up arrows so you have your history. I want to give this container a name. Name something. All right. So this time, when we do this, we get what? Now, what's going to show up in our list of containers? Hey, look, something, right? Now, watch if I try to do it again. If I try to go and repeat the same command, it's going to say, nope, I already got one named something, can't do it. Like, okay, well, can I run it? So again, this is just like all the other ones, except for now we have a named, right? Well, what if I actually just want it to execute this existing container? You know, I mean, we're not going to go there. There are so many things you can do here with containers. So I wanted to give you, yeah, I almost named it that, Porky Bash, the reference to 2 years ago. So we're going to go ahead and do something. Now, I want you to go experiment, RWX, experiment, explore, play around with the whole container space. The only reason that we are using containers right now for our purposes is so that we can practice doing things with Linux, like installing software and running VI and, you know, deleting files and seeing what happens if we blow away the root file system. We're going to do all of those things in a container, right? But I had to kind of give you this introduction to the Podman command and to these containers before we do those things, okay? Rather than just doing, you know, following along. But here's your homework. Play with Podman, play with those other container things. It's going to take you a long time to get all of the commands down. But the only command that you have to know right now, and in fact, when I was writing my notes this morning, some people saw me like simplify this thing. I had all of these commands here, right? And then I ended up concluding with the singular command down here, open and run a new temporary command with the Podman command. That is all that's required for the boost. Now, those of you who know about containers and all that there is to learn there know that I'm skimming over a bunch of stuff. But in order to keep us moving forward and getting to the next part, which is learning how to script and navigate and change permissions and use VI and use tmux and search from the internet, from your command line, all of that stuff requires us to just get to know enough Podman to run a Linux instance, temporary Linux instance from a container on our desktop. That is the goal for now. Okay. So here we see we have all these other containers, and I wanted to, we're gonna kind of abandon the Podman Desktop for now. You can always come back to this if you want to lean on it, but we're gonna go ahead and delete these extras here. Nice interface for this. By the way, if you click prune containers, it will delete any container that is not currently running. Yeah, so that's a nice thing. By the way, some of these commands are so convenient that I can't even remember what the command line equivalent is. So keep that in mind. I mean, like when you go, this see how this pulled down these different images, right? Oh, look, here's one. Let's go ahead and I forgot, I skipped over this. Let's pull an image. Let's pull an image that I know of, right? A container is an instance of an image. Yes. So let's pull down my workspace, rob/workspace. This is off Docker Hub, so there's no preface to it. Pull image. So all this does is pull down this really big image. This is going to take you a while. It's about 2 GB image, which as images go is pretty darn big. It's not as big as the stuff I've seen in our machine learning environment, but still it's pretty super big. Now, so it's still pulling the image. It's got the download complete. And now it's done, right? So now we can see that I have the docker.io workspace image is here. It's a pretty old one, 2.16 gigabytes. And now watch, we can actually, if you click on play right here on the images, it will start a container and run it. So you click on play there. It's like, which kind of things do you want here? You know, but instead of doing any of that, we're going to do it from the command line like we just saw, right? But we're going to delete the image, and I want to show you how you can do. So if you fast forward through the whole video, hopefully you got to this part, because we are going to prune all the images. We're going to get rid of all of them. We don't use any of these images. Pruning images is like, I want to delete all of the images that are not currently being used for running containers. Okay, so it took a while to delete them all, but you see now we're all gone. By the way, those things take up space on your disk drive, so you know you don't want to have them laying around if they're not being used. But if you know you're going to use the same image lots, then it's good to have that. Okay, so here's the command that you need: Podman run, right? And so now you just have to memorize this. Podman run -it, run it. That's how I remember it. Run it. The I stands for interactive, and the T stands for TTY. In other words, give me a terminal. Well, I don't want to just run it. I want to run it and connect to it so I can start using it, right? And then if you don't want the container to be around after you exit, and so it has to go be cleaned up, you can type --rm. And so what that does is it says when that container is instantiated from the image, right? It'll pull down the image if it does. So what does this command do? And then I'm going to do rwxrob/workspace. Okay. So this does a lot in one command. If there's one command you need to write down, this is it. So what this says is download. Run means pull and run it. That's what it means. It means pull it and start it. So pull it and start it, or there's other commands in there, execute, but so pull it and then run it. And not only run it, but run it and connect to it interactively with a TTY or terminal, interactive terminal. You can think of, it doesn't stand for that, but you can think of IT standing for interactive terminal. Run -IT, interactive terminal, --rm. That means clean yourself up, delete that instance when we're not using it anymore, and then here. All right. And then this, so when we run this, you'll see it's going to take all this time downloading these blobs and getting them. So it goes to docker.io because we didn't put it there. And it's going to take a while because it's got 2 gigabytes. It has to pull down 2 gigabytes. So as I said, that's rather large. Why is it so big? Because this, unlike Hello World that we just did, this isn't just one command that's just going to go away after that. This is an entire simulated Linux workspace environment. That means it's all of Ubuntu server plus all of my personal configurations, including fishies and colors and everything, and all my Vim config. So if you actually want to go see my workspace interactively and play with it and then throw it away later while you're working on yours, this is what you can do with your containers. Now, when my workspace runs, it actually, the first program it runs actually prompts you for a few things. It asks you, hey, do you want to, what kind of user, what do you want the user to be? And for the purposes of this, you can just accept all of the defaults. Okay. So we're going to say you, and the user ID, that's the number that goes with your name. We'll use 1,000. We'll use the group name you and user group 1,000. We're going to say home you for my directory. And we're going to say that we want the bash script. So these are the defaults. If you know about these things, you could actually set these to be something different. And what that does is that creates a Ubuntu Linux machine with the account name you. This number right here is the automatically generated host name for this container. Now, if I go back into our GUI and we go look, and up here, you'll see Hardcore Chalet. You'll now see that I am running. See, I'm running right there and I'm connected. In fact, you could even connect a terminal from both places. And, you'll see that, look, user share rwxrob/workspace. That's the default for that. Now, if I were to do, this is, okay, so let's talk about this. This hashtag means that it's running as root, right? And root is just admin. That means they have access to everything and they can go ahead and break everything, which we're going to do. But by default, root is the default. But if you use my workspace, I didn't want to do that. I wanted to be able to set it up as an individual user, and come in and do the things here. But if you want to come in and do fishies, or do I have Neo over here? No, I have C matrix. T matrix I think is over here. Yeah, we have the T matrix over there. So if you want to go over there and just play around, you can. But now let's actually talk about a few images that are more useful with our few minutes left. We only have about 6 or 7 minutes. So what are some other images right away that you can play with, right? So let's try. As I said before, we're going to just use everything on the default Docker Hub for now. Let's go through, we're going to say Ubuntu. Okay, so we want Ubuntu Linux. And now it's going to go grab Ubuntu Linux. And now we have root by default. Notice the prompt. We now have the root user. We have this generic ID that's assigned for that machine. And then we have the hashtag. That means that we're a root user and not a regular user. In fact, there are no regular users on this machine, right? The only user on Ubuntu by default is root. So something to keep in mind, most containers that run, that look like operating systems when they run as root, unless you specifically create an account on here. And that is one of the things that we're going to do. So we're going to do basics like how to create a basic user administrator account on here, and how to set that up and how to configure that. Those are all things that we're going to do in the boost, without getting into too many details, not to the level of certification. But now something that's interesting. So let's go back to the GUI again, just for is it still there? Where's my Podman Desktop? Is it still running? Should be running. Where did I kill it? Let's go Podman Desktop. Let's go run it again. All right, so let's go back to our Podman Desktop and look at our containers again. Okay, so now we have an Ubuntu container that is running. That's the image. So let's go to the containers. So we have nice pane. See how it did it? So we have a running Ubuntu container. What happened to my other container? The workspace one. The workspace container, because we did --rm, was deleted after it ended. After we exited, it shut it down and it deleted the container. It's like, okay, you don't use it anymore, right? And that's super important to understand that. Normally when you shut a container down, it's meant to be ephemeral, which means that you just chuck it, you just throw it away. And anything that you wanted to keep around, you would have mounted and written to some other place. For our purposes, that's fantastic for testing because we don't want it to keep anything around. We want to repeat the steps, right? And we want to write those steps down in our notes so we can practice those steps over and over again. And one of the reasons that containers and virtual machines are so good for education is that you can kind of save them along the way at different paths. In a virtual machine, you can do something called a snapshot, which freezes that machine at that moment in time. And then you can do dangerous experimental things and snap it back to the place it was before it got killed. You know, you can do the same thing with containers. It's a little bit more difficult because containers in general are designed to be really thrown away and then, brought back. But you can leave a container running, which we're going to talk about next week, because we want to have an ongoing container that we are going to, a Linux machine in a container running in a container that we're going to build up over time. And normally that's not something you would do, but for the sake of our practice and education, it's fine. And then if you ever wanted to, you can also try out different versions here of Ubuntu. So here we have, watch what happens when I type exit. So when I type exit, it goes away and the container is gone. Now watch what happens if I get rid of the RM. So if I get rid of the RM and now we do it, see how fast it ran a new one? Why? Because it's already pulled the image down. You know what's really cool is that if somebody updated the image and I do run like that, it will detect that there's been a change to the image and it will grab the latest version of the image, update it automatically, and then dump you out on a command prompt. So this is a super important part of this. So here we have it running, and you see it's running. Now watch, when I type exit this time, boom, it goes, wait, it just exited, it kept it around. Uh-oh, right? And now can I type run again? I can. Now it's running, but I'm not connected to it. Okay. The way, I forget the command actually. It's like run Podman, is it connect? I can't remember. I don't even use the command. What is it? Someone help me out. Is it login? It's not run. If we do run, it'll make a new one. I didn't want to do this because I didn't want to freak people out. Attach. Yeah. Attach to there. I just tab. I hit tab and it told me what one to go to, right? And now we're going to need, I think we need IT for this too. No, it's not IT. If it's running, right? So now we just reattached. So now we're connected back to that one that we were before. If I type exit, but if I try to attach it, see how it exited? What happens if I try to attach one that's it's not running? It's like, oh, it's not running, right? So then you can do Podman start elated, and this will start it, and then you can attach to it, right? And then you type exit, but by default, when you type exit, it turns it off. Yeah. Okay. And so it really depends on the image and stuff about how you want to do it. But again, if you don't want it to do that, and how do you delete it, right? Podman, delete, I think. Is it delete or RM? I don't remember. There it is. I don't do it very often. So now that image is gone. Okay, so that is really your homework for this week, and we're done. It's 1 o'clock, so we're gonna go ahead and end. Your homework is to get Podman working and start to play around with those commands. Now, next week, when we do this, we are gonna learn all about how to deal with files. And how to set up the operating system and how to do more. But for right now, play around with some of the different images. Let me give you some of the examples. So using that exact same run command, you can sample different operating systems, different Linux operating systems. So you do RM, right? So you can actually do Kali Linux, Kali, I think it is. So denied resources, what is it? What's the Kali Linux one? Running manifest, latest Docker. I think they moved Kali off of there. What is it? I can't remember. If you want to try, okay, so you could do Red Hat if you want. Quay.io, Red Hat. Basically, find a whole bunch of images. That's not one. I don't know. How about Fedora? Dora. I don't even know what I'm doing. I'm just guessing at a bunch of images. Kali rolling, that's right. Kali Linux, the hackers out there will know this one. But, have fun with this, exploring it and looking at all the different ones. This is one of the main reasons to use containers is that you can see all the different things. So this is a Kali Linux. This is Kali Linux running from the command line. It doesn't have a lot of good stuff in it because it's a very limited version of it. But you can try that. Here's another one. You want to try Arch Linux? You always wanted to try Arch? Try Arch. I think Arch is Arch Linux. Arch. I can't remember. Anyway, try them all. Which one is it, guys? Is it Arch? There's a bunch of them. I mean, I can't remember them offhand. Ubuntu is the one. You could try Gentoo if you wanted to. Arch. My favorite one is Alpine. Alpine is the smallest Linux besides BusyBox, and Alpine is like one step above BusyBox. So this is Alpine. You can also do BusyBox. So BusyBox and Alpine are the 1 and 2 most popular container images. Ubuntu is probably after that is the most popular mini Linux distribution when somebody wants more or less a Linux distribution to go with their application and put them all in there. So those are the ones I would definitely know how to do. We need... So BusyBox is by far the smallest Linux distribution in planet Earth that you can generally use for containers. And there are others. It fits into 1.5 megabytes, by the way. And you can do Alpine is another one. Alpine doesn't have any GPL v3 Linux in it. If you know what that is, it's very, very popular. It also, these do not have bash shell on them. They have other shells on them. This is one of the reasons I like to use it, to demonstrate why you should progressively learn VI and ed and that stuff, as well as Vim and all the other stuff, because these containers only have a minimal version of VI in them. And there's Kali Linux. You can go look at that one. And then there's... I wanted to get Arch to work. I can't. Why am I not getting... What's Arch? I have to go look it up. Give me a second here. I got to look up Arch. So, and we'll say try... Let's see. Ubuntu. Which one is it? It's just Arch Linux? Really? Okay, let's try that one. Arch Linux. It is. Okay, so there's Arch Linux. Some people are big Arch Linux fans. You can actually, I think Arch Linux is the best container for creating a security distro of your own. So in fact, I was extending Arch Linux some years back to make my own security command line container distro. And if you know anything about security, you know how important running this kind of stuff in protected containerized environments is because of security concerns, right? So that's one of the reasons to use containers is because if you know you leak information about how to get to your computer, who cares? It's just inside of a container. I mean, there's a lot of considerations there, but having a container in a virtual machine is one way to protect yourself during discovery and that kind of stuff that you would do in security. And Arch Linux is a popular distribution with those who like to customize and do things like that. Gentoo is another one, but it's a different flavor. In fact, I don't even think it has an image. Does anybody know? I don't think. No, it doesn't. Okay, I don't think it does. So those are some to try, and that should be enough for today. So try Ubuntu is the one we're going to be using the most. They all have different package managers, which we're going to get into, if not next week, the week after that. And that's how you manage installing software. And so the reason that we're going with Ubuntu, what's the Red Hat one, by the way? So there's a Portage container, really? Okay, so try Ubuntu, Kali Linux, Kali rolling, Kali Linux, Kali, is it Kali rolling? Let's put them all here for everybody. Which one did we do? Kali Linux. Oh, wow. I did tab and got tab completion. That's because it was downloaded already. Kali Linux, Kali rolling latest. Okay. What else we got? We got BusyBox, Alpine, Arch, Linux. Yeah, let's just put these all in here. And these are kind of fun. BusyBox, Alpine. This will be in the notes if you haven't seen it already. They'll turn into notes for the YouTube video. Kali. Now, notice that you can't use BSD, right? You can't use BSD and you can't use Windows, or you can't put Mac in there, because those are different operating systems. And back to about the virtual machine. The one fundamental difference between containers and virtual machines is, for the most part, virtual machines can emulate different operating systems, like at the lowest level. And if you go even further than that with something called KEMU, K-E-M-U, which we talked about on the first day, you have an emulator that can then run things that simulate entirely different hardware, right? And so you have all these different layers of abstraction at the expense of speed, depending on what you want to do. When you're on a container, though, you'll notice that there are no BSD versions of Unix, or Solaris or something that we can run in a container, because the containerization, as is referred to, the idea of containerization, BSD has something called jails. Those are containers for BSD. But generally, when we're speaking about container, I'm just going to say it again. A container is an LXC. It's a Linux technology for the most part in modern times, where it has to be a variation on the Linux kernel. That means that you can have all these different types of Linux that are all using the same host Linux kernel that you're currently running, right? So they're using the Linux kernel that is being provided by your engine. Now you're like, but Mr. Rob, I'm on Windows. I don't have Linux on here. Well, behind the scenes, Podman Desktop is providing a specific Linux kernel for all of your containers. And you don't need to care about the details of that. But it goes without saying that if you wanted to, you could install, and that's what I'm doing on Anton. I don't know if you noticed this, but that's what I'm doing on Anton. You can run your own virtual machine and then install Docker or Podman into that virtual machine instead of using a fancy desktop, Podman Desktop kind of application like that includes a virtual machine inside of it. That's quite a bit to unpack. So make sure you pause it and re-listen to that so that you understand what that means. But a lot of people, when they see me using Podman Desktop, I was like, why don't you just install a virtual machine and then run Podman on that? I was like, well, you can totally do that. If you do that, then you have more control over the virtual machine that's running your containers. But if you don't care, then something like Podman Desktop or Docker Desktop is better, because it takes care of all that hassle for you. And if you're running on a Mac M1, or M whatever, that's using ARM, then you're going to start to have hassles, because you got to you find a virtual machine engine that actually works with your hardware, and it's not beginner stuff. It you know, it can be done, but you know, up until very recently, they weren't even, VirtualBox even came out with a thing saying they were not going to support the new Macs, and now they say they are. So if you want to get into the nitty gritty of virtual machines and then installing, you know, Podman or Docker onto those virtual machines, you can certainly do that. But the faster way to go about it for most beginners is going to be install Podman Desktop, and boom, now you have your containers, right? And you're going to need containers no matter what, because almost everything needs containers these days. So, you know, even if you do decide to do a virtual environment to learn Bash, it would make, you know, it would be good for you to learn how to do the Docker stuff or the Podman stuff. All right, that is all we have for today. So go ahead and play. And then we are going to be doing, so for next week, you should be able to start up gitbash, navigate around your file system, understand the differences between your graphic user interface and your command line interface when it comes to the file system, and know how to list things, know how to move around. CD, by the way, we didn't cover that, but CD changes a directory. Go ahead and, you know, change into a directory and then go up. We're going to do all of this stuff much more next week. But the main takeaway is that you can get Podman, you understand what a container is, that you can start up a container running one of these Linux variations, and that you understand how to get rid of them, and you've played around with the commands from the command line or using the Podman GUI and desktop. You should be able to start and stop containers by next week. You should be able to start and stop containers without a problem and get on there, and you should be able to start minimally understanding how to navigate through those things. So next week, we're going to spend all of the time on navigating the bash command line, dealing with files, creating them, destroying them, moving them around, organizing them, and possibly even starting to integrate those files with Git and GitHub so that you have a backup copy of the stuff that you most recently pulled down. And when we talk about how containers get thrown away all the time, right? Well, you're wondering, well, what happens if I do some work and it gets thrown away? Well, that work should be saved into GitHub, right? So we're probably going to cover that next week. I don't know if we're going to make it in time though. We'll probably have to do that the week after that. So that's where we are. But you should have enough to really sink your teeth into it and play around with containers. You can read more about container and virtualization in general. And that's going to be it for today. I'm just going to go through the chat really quick, see if there's any big questions I missed. RISC-V hardware. Which constraints would run natively with RISC? You can't run RISC-V at all for any of this. You need QEMU for that because it's a different hardware architecture. Gen 2 stage 3. Oh, so there is a Gen 2. Yeah, let's try that. Gen 2. Gen 2 is another one. We're going to talk about what Linux and Unix are next week, and these different distros and why they exist, and you know why Linux period, all that. That's all coming next week too. But I wanted to get something in your hands so you can start playing with. All right, so we'll cover these next week. See if you can find the differences between the two just on your own. That'd be kind of fun. Oh, you found Red Hat? Nice. Thank you for that. So Red Hat Ubi 8-minimal. Thank you for that. That's actually more important than Kali and all these others, but great. So yeah, thank you for those references. Appreciate that. Containers can be unsafe. Yes. Containers are generally safe. The only time they get unsafe is if people can break out of the container. Most of the people who attack, that's what they do. In fact, one of the reasons to use Podman over Docker is there's less to attack. And that was a very big controversial thing is the attack surface of Docker, the Docker daemon, which is the central process that manages everything, we had to run as root. So that means if you broke out of the container, you got root access to the host system. And that was a serious security concern for a very long time. Did I write the wrong thing? Red Hat. Thank you for that. Good catch. It's probably time for me to go. Let's see. Universal Basic Image, Gen 2 Stage 3. I think that's about it. Did we skip Podman machine init and Podman machine start? Yes, we did skip that. Okay, so if you want to use the command line entirely, my friends, I'm glad you reminded me that, Dan. So pull an image, start a container. Okay, so I don't know if we should complicate the issue right now. So Dan is reminding us that there is that there is a, how about this, understand equivalence from command line. So Podman has, unlike Docker, Podman has an extra command called Podman machine init that you have to run so that it can start doing all of these things. But we bypassed the need to do that by using the Podman Desktop GUI. And so, Dan, that is a good point about Podman machine init. If you were doing all of these things without you know what? Let's do that next week. So next week, what we'll do is we'll do the entire thing without using the GUI. Period. We won't even start Podman Desktop GUI. We'll turn it off. We'll turn the daemon process off, and we'll pretend like the machine was rebooted, and we'll do all the commands, including Podman machine init. And we'll deliberately try it and hit the error so people can learn it, because I don't think they're gonna hit that error. Is the Ubuntu image that you pulled the server version? Yes, by default. Yep, it sure is. Okay, and that's all. So a good point though on the Podman machine. So Podman, unlike Docker, does have an extra step with Podman machine init, but we will hit that on purpose next week. And you'll see that if you don't want to use the Podman Desktop GUI, which you may not always have, you might be working on a remote system that doesn't have a GUI that you have access to. So you would need to know that command. But let's show that command next week. Alrighty. Bye, everybody.